At this point, I'd like to welcome Luigi Puglia, who is the Wire and Cable Market Manager for North America for Arkema. He has 30 years experience in the plastics industry. Luigi?
Okay, so I'm Luigi Puglia, the Market Manager for Wire and Cable for Arkema, and we supply Kynar PVDF. We're the world's largest supplier of this material. I'm going to talk to my presentation basically is focused on cable designers and how the utility of PVDF is used in cable design. So let's go to the first slide. We supply over 20 different grades of PVDF to cable designers, and they're used to overlink to overcome a variety of challenges that cable designers see. We're going to talk about temperatures, processability, cross-linking, smoke and flame requirements, different melt flow rate or viscosity ranges, chemical resistance, and polymer processing aids with PVDF. So let's get going. What is PVDF? So PVDF is polyvinylidene fluoride. It's a fluoropolymer. Basically, here's the chemical structure. You can see it down here. And PVDF, if you think about it, it blends the processability of polyethylene with the inertness and temperature resistance of TFE. So PVDF is a fluoropolymer that's been around for a long time. We started producing this material in the 50s. The nature of PVDF is that the carbon-fluorine bond is extremely strong. That's the strongest bond in nature, and that's what makes this material very, very tough. Go to the next slide. From a global supply, PVDF, in order to produce it, you need to mine this rock. It's called fluorspar. It's a fluorine-containing mineral, and we take fluorspar and we synthesize it through our emulsion polymerization method, and we generate a latex. We dry the latex to a powder. We densify the powder and extrude pellets. So most people in the cable world utilize pellets of PVDF in their extrusion of cable jackets. Arkema has 3 facilities where we produce PVDF, one in China, one in France, and one in the US. The US is the world's largest PVDF plant in Calvert City, Kentucky. So let's talk about cable design and what typical cable designers look for, what kind of characteristics. If you look here on the left, you'll see various different types of cables, from fiber to copper to E-beam cables or thin wall tube. And here we see most of the characteristics that cable designers look for. So for an example, in fiber cable, most designers seek a very flexible material, flexible cable with a high melt flow rate, frequently plenum rated, with a low temperature impact resistance and extremely low shrink back for the cable jacket. You'll see here in the copper world, sometimes they require plenum service, frequently over 150 degree rated service. Some low impact temperatures are sometimes required. And you can get an idea of some other materials that are, let's say, optimized for toughness. They have different requirements here. Their flexibility is not necessarily so high. They can live with a stiffer cable, and you can just see what the characteristics are. So what we are going to try to do in this presentation is to show you, based on the characteristics that cable designers seek, what grades of resin can be used to utilize to meet these requirements. So here's a list of about a dozen different grades that we provide, and a variety of their different characteristics. So let's just jump to the bottom. Kynar 3030, that's a very high melt flow rate material. It's plenum rated to 150 C, has low temperature impact, has very low shrinkage. So this is favored by fiber designers, the 3030 type cables. Conversely, the Kynar 460 PVDF Melt flow rate is very low. It's rated to 150 C. So if you see this list of different grades, you'll notice that the flexibility goes from very low to very high. So depending on your requirement, you could choose a grade or flexibility. Just be cognizant that the stiffer materials have a higher chemical resistance. So the more you go in higher flexibility, the less chemical resistance you have. Although, you know, PVDF is a fluoropolymer that has very good chemical resistance, the stiffer grades give, you know, better resistance to chemicals than the more flexible grades. The flexible grades are copolymerized with HFP, hexafluoropropylene, where the homopolymers are just PVDF 100%. So the next slide, we frequently get a question by cable designers, you know, on various properties, like what's the best grade to choose? So here's just a snapshot of the most common questions, you know, for low shrink back. Frequently fiber optic cable makers will ask us, which is the best grade? Well, our Kynar 3030 has the best low shrinkage. We'll have slides on that. But a grade we previously manufactured, we still supply today, 2950 has very good shrinkage. Low temperature, 3030 or 3050 are extremely good. You'll see slides on that. But this other heterogeneous grade 3120 is very good, but not as good as the 3030. 150-degree rating, we have a variety of materials, homopolymer and copolymer. PVDF is able to be cross-linked. Cross-linking increases the service temperature of the material. So these grades here, 3120 to 2750, are common Kynar grades for cross-linking. Clarity, this grade here, 2500, has a very good clarity. It's very translucent. 2750 is pretty good as well. Chemical resistance, these grades here, 460 and 2850, are very good, very stiff materials. 3120 is very good for chemical resistance. And toughness is the same thing. So this gives you kind of a thumbnail guess or direction where to go to choose you know, the material based on what your requirement may be. Go to the next slide. For low temperature properties, we get this question all the time, which are the best grades for low temperature? The absolute best material that will take a low temperature impact is this grade Kynar 3050. This grade will withstand a temperature, a cold temperature impact to -60. We have another grade 3030 that will take an impact to -25. So these are not manual tests, these are physical impact tests. So if you have a low temperature application, these are the grades you may want to consider. Let's talk a little bit about viscosity and melt flow rate. As you can see here, we have some low viscosity grades like Kynar Flex 2950, 05. And you can see its viscosity is 8, melt flow rate is around 20 with a 3.18 kilogram load. One of the benefits of a low viscosity material is this enables you to extrude faster. So a faster speed in production, lower shear rate. This lends itself to a shiny surface on your cable. You can also make thinner walls when you use a high melt flow rate material, and shrink back is dramatically reduced when you use this type of material. So low viscosity or high melt flow rate material will give you these attributes. On a high viscosity or low melt flow rate material, the benefit of that high viscosity is that you can extrude a thicker wall. So if you maybe typically a chemically resistant type cable would require a thicker wall. So by using a high viscosity material like the Kynar 3120, you'll be able to achieve that. Also, most cables that are cross-linked also use a thicker jacket. So this high viscosity material would lend itself to that. And from an impact point of view, thicker is better. So if you're looking to, have a dramatically strong, impact resistant material, I would go with a thicker jacket. This slide here, slide 12, talks about the range of service of PVDF. You can see from the very lowest, -60, all the way up to 150. We have a variety of grades that will meet your requirements. And if you see here at the bottom on the left, the grades go from softer to harder. So depending upon what characteristic you want your cable to have from a very soft, flexible, let's say fiber material, fiber cable, to a very stiff, chemically resistant, harder cable, you could choose the straight 460. The glass transition temperature of these materials is around -40. But again, as we mentioned in a previous slide, if you have low temperature impact requirements, the 3050 will work very well, as with the 3030. And 3120 is in the same heterogeneous family as well. So this just gives you an idea of where you could use the PVDF as a cable jacket. This slide talks about cross-linking. PVDF is cross-linkable. All PVDFs are able to be cross-linked. So if we have a upper service temperature of around 150 C, you can boost that to 175 C by E-beam cross-linking. The one thing we would always recommend is using a cross-link promoter like TAIC. The use of TAIC will enable you to reduce the dosage of E-beam, and yet allow you to raise the surface temperature up to 25 degrees or even higher. Typical E-beam dosage is around 6 to 10 megarads when you use TAIC. Without TAIC, you may have to double this dosage, but when you double it, you would reduce the crystallinity of the resin. You would also incur a darker material, and then change scission would ensue. So our recommendation is always to incorporate TAIC whenever you want to cross-link any PVDF. This is a well-known technology, known for many, many years. Shrinkage, we always get this question, especially from fiber customers. What grade should we choose to have a low cable jacket shrinkage? Years ago, we had developed Kynar Flex 2500. Its shrinkage rate is around 0.6%. This is measured from room temperature all the way down to -40 C. So it shrinks at around 0.6%. But of late, we've developed this new heterogeneous grade, Kynar Flex 3030, and its shrinkage is about 0.4%. So it gives the best low temperature shrinkage coefficient of thermal expansion available in PVDF. Go to the next slide. Smoke and flame resistance. PVDF is inherently smoke and flame resistant. The limiting oxygen index value for unadulterated PVDF is around 40. That means you need 40% oxygen in the atmosphere to get it to ignite. I think the atmosphere is around 20-some%. So PVDF on its own is very, very good for smoke and flame resistance. And the UL 94 rating is V0. However, if you add a smoke and flame package to PVDF, as we have, you can increase the limiting oxygen index to greater than 90. This allows cables to pass NFPA 262 and plenum conduit standard UL 2024. These particular photographs are the UL Steiner tunnel test. This tunnel is 25 feet long, and here's you can see the yellow cables that are prior to being burned, and then here they are after they're subjected to the flames. In this particular test, the flames only reached 3 feet, and the flame spread kind of ended there. With other types of materials like polyolefins, you would have the flame spread go the length of the tunnel. The interesting thing about PVDF is that it intumesces when it is burned, which means that it chars, it forms a char. So in smoke and flame applications, you don't want any dripping of the polymer onto, let's say, a rug, because most people perish in fires from smoke inhalation. So by using PVDF, you encapsulate all the interior polymers inside this intumescent structure of, that is generated, and it allows for a longer escape time for people that are in a fire situation. So this is why PVDF is primarily used in plenum cable, for its great smoke and flame properties. It protects what's inside the cable. So generally, PVDF is used on the outside, and lesser materials are used on the inside because of the great smoke and flame properties of PVDF. Environmental resistance, or chemical resistance, PVDF being a fluoropolymer has great, hydrocarbon and fuel resistance. Halogen salts and acids have little effect on PVDF. There's no oxidation, no antioxidants or stabilizer are used in PVDF because of their inherent, its inherent fluoropolymer nature. It doesn't need that. Therefore, it's able to withstand long-term heat aging. There's nothing to leach out of the PVDF. UV resistance, PVDF is inherently resistant to ultraviolet light. It's not affected by it at all. So in typical outdoor cable applications, customers would pigment the PVDF jacket black typically, or any color you wish, and there would be no adverse effects from UV. It's commonly specified as an indoor-outdoor cable jacket. Abrasion resistance of PVDF is great, especially the homopolymer grades. The only other polymer that's more abrasion resistant than PVDF is ultra-high molecular weight polyethylene, which is extremely difficult to extrude. So from a cable point of view, PVDF is a very, very tough material and is excellent in abrasion resistance. Here's a list of more chemicals. The typical questions we get, is your material resistant to chlorine and acids and all these different chemicals that are listed here. If you would like a more detailed list of what chemicals our material is good for, or how the results, we have a 12-page chemical resistance guide. Just go to our website and or send me contact information, and I'll gladly send you the chemical resistance guide. Let's go to the next slide. Processing. A key element to using PVDF is that it is the only fluoropolymer that can be run on conventional extruders or molding equipment. If you can run PVC or polyethylene on your extruder, then you can run PVDF. It's just as simple as that. So anyone that is not in the fluoropolymer business and they want to get into it, they can by using PVDF. So you can see the temperatures, the extrusion temperatures that we recommend, and the drawdown ratio and draw balance, land length that we typically recommend. In running PVDF jackets and wiring cable, we recommend tube-on extrusion, but you can pressure extrude as well. Typical line speeds are about 300 feet per minute, depending on which grade you choose. Generally, a jacket of 15 to 25 mils is normal, but you can always go thinner or thicker. If you seek a shiny cable jacket, that's achievable. If you want a matte finish, just have to lower the dye temperatures a little bit, and you get a matte finish. We always recommend a lower drawdown ratio. If shrink back is involved, we're concerned, and we always recommend barrier screws rather than metering screws. So this just gives you a thumbnail idea of if you don't have a fluoropolymer machine, you can run PVDF on a machine that is capable of running PVC or polyethylene. If you want more details, just contact me. We're coming to the end here. PVDF is also used as a processing aid, especially for polyethylene or polypropylene jackets. So should you have a melt fracture, like you can see in this top photograph, in your polyethylene or polypropylene jacket, the addition of an extremely small amount of PVDF, we're talking 500 parts per million, will turn your jacket from having melt fracture to none at all. You can see here on the far right, this top right photograph is a picture of a cable jacket being extruded and the die drool that is being generated. When you add PVDF as a process aid, the die drool is eliminated and the jacket comes out nice and smooth. Now, in order to get such a small amount of PVDF into your extruder, you would use a master batch. So there are master batch makers of PVDF. Just have to tell them what grade of polyethylene or polypropylene you use, and they will match the master batch to that. Again, it's an incredibly small amount of PVDF. It migrates to the outside of the melt stream and allows the polyethylene or polypropylene to slip on through and eliminate the melt fracture and die. Here's my contact information. We're pretty much at the end of the presentation, but should anyone want to email me or want some literature, this is my contact information. Please feel free to send me a note or give me a call, and I'll be more than happy to help you. So we have a couple minutes left if anybody has a question.
Thank you, Luigi. That was a lot of good extrusion knowledge you shared. We do have a few questions. Can you talk about smoke emission of PVDF?
So smoke emissions, if you use a smoke and flame grade that we have, the smoke and flame generation will be minimized. And we have many instances where grades or cable customers that are on maybe the fringe of passing the UL test have switched to a PVDF grade with our smoke and flame additive, and smoke and flame generation was eliminated so that they could pass the test. So yeah, that's common.
Okay. Another question, is PVDF moisture cross-linkable?
Typically, you can get, we always recommend E-beam cross-linking, and all the technology and all the commercial uses for or cross-linking use E-beam cross-linking.
Mm-hmm. Okay. Is PVDF available as a powder?
As a color, did you say?
A powder.
A powder, yes. We make PVDF in a latex form, in a pellet form, or a powder form. So in many instances where customers want to maybe add other raw materials into their compound, they may use some PVDF powder and incorporate that powder so it more easily blends with the pellets.
Is PVDF resin available in a variety of colors?
We do supply a PVDF in a pre-pigmented form in a few handful of colors, but there are color concentrate suppliers that would supply, any pigmented color that you would need to pigment, a cable jacket. No problem.
Okay. And in terms of possible future grades, are there any new customer products on the horizon that might lead you to come up with a new grade, something that will be required?
I will tell you that we have recently developed a foaming concentrate, and so that's being used in some applications to make the cables lighter in weight. This is frequently required in aerospace applications. So that's definitely available. We have that type of material available, and we're always developing new, the next generation of materials. But because of the virus these days, things have kind of slowed down. So, that's our latest technology.
When it comes to creating a new grade, Is that a matter of tweaking an existing grade, or is there a lot more going into it?
You can see that in the past we had just homopolymers, and then with the advent of plenum cable, we developed copolymers with HFP, and those were homogeneous materials. And then we went and changed recipe to, or added heterogeneous materials. So recipe was changed. So you go from changing recipes to sometimes putting additives in. We have the one grade that's good to -60. We have realized the benefit of the low temperature impact by adding a new raw material to give us that superior low temperature. So it's a combination of recipes or raw material changes. It's mainly driven by customer requirements. So depending on what the customers ask, we had aerospace applications for light weighting, and so we developed the foam. So it all depends on what our customers require.
Can your product be used with XLPE to get smoother XHHW?
Can you say that again?
Can you use this with XLPE?
Yeah, you could use it to eliminate melt fracture. Sure.
Well, thank you again very much, Luigi. It was a wonderful presentation.